How organisms employ conservation of momentum principle in their locomotion. Momentum is a physical quantity expressing mass times velocity in a system with two or more masses. If there are no external forces acting on the system, the momentum is conserved. In collision problems, momentum is conserved, since the interaction between the bodies is an internal force. In an explosion of a bomb, again momentum is conserved because the explosive interaction force is an internal force of the system, which is the bomb itself. Conservation of momentum principle is applied frequently in technology. Jet engines use this principle in building thrust force for the planes. The system is the fuel and engine. When fuel is burned and exhausted with a high speed from the rear of the engine, to conserve the momentum of the system, the engine moves forward. Rockets use the same principle to attain extremely high speeds. Is there any application of this principle in the locomotion of creatures? The answer is indeed yes. Squids, octopuses, scallops heavily depend on this physical principle for locomotion. Squids draw water into their inner cylindrical chambers through slits on either side of their heads. By spraying this water through a thin tube under high pressure, they achieve motion in the opposite direction using the principle of conservation of momentum. The locomotion of octopuses is quite the same with squids. Japanese squids move at an average speed of 0.3 meters per second during their 2,000-kilometer migration, which lasts from 2 to 5 months. For short distances, their average speed may be as high as 3 meters per second. When threatened, the speeds are much higher, leaving a cloud of ink behind them. Another organism using conservation of momentum principle is scallops. Its hardened shell can protect it from many enemies. The predatory starfish is an exception to this. The starfish wraps itself around the scallop, placing its legs in a row on both shells, and pulls until the muscles tire and the shell opens. The only defense for the scallop is to run away from the starfish. The scallop takes in water by opening and closing its shells, and then expels it with high pressure in a series of leaping motions forward and upward. Organisms are not only perfect structures, but they are also programmed to employ physical principles during locomotion in the most efficient way.